welcome to today's video. Got the leading edge sim Saab 340 with an X-Plane 11. I'm going to be looking at another takeoff, can be slightly different for today's. Just before we get going, just got a little chart I've knocked up here to clarify a few speeds that we're going to be looking at. So first off, because manoeuvring is part of this, so according to Saab, manoeuvring is defined as a coordinated turn in excess of a 15-degree bank angle. So we've got a couple of speeds down here that will depend on the configuration. There would be a little half bank button just here in the Carenado Saab. There is one, the leading edge one, there's not. That would limit the autopilot authority to 13.5 degree bank angle. V2, most people know it's takeoff safety speed, or the one engine inoperative speed required to comply with aircraft certification climb gradient standards. Typically for the Saab, V1 rotate and V2 are all the same speed, so just courtesy of the runway length. Now these speeds I've put here are just based on weight only, no runway or atmospheric conditions are factored in. So flap 0, 123, flap 15, 112, that's at max takeoff weight, max landing weight down here for the landing ones. Now V-clean is a Saab term. They define it as the final climb speed. From there, we also have V-clean plus 15, which is the minimum non-maneuvering speed for climbing icing conditions. So that'll be with the half bank button on. Otherwise, V-clean plus 25 if you want to turn the half bank button off. The flap retraction speed is V-clean minus 3, so at max takeoff weight 128. And then the VREFs, which is the target speed 50 foot above the runway and the landing configuration for flap 20, 117, flap 35, 113. Also just put the manoeuvring speeds in here as well. So it's the minimum speed for various configurations during an approach. So one speed, or the normal speed, and then the speed if you're in icing conditions. Obviously, ice on the airframe changes the aerodynamics, and that will therefore increase it'll decrease the angle that the wing will stall, which would correspond to an increased speed. So in all cases, it's 10 knots more in icing. Otherwise, holding at 160 or flap 0 at 150, which is also holding, but they define the two separately. So flap 0 then reduces by 5 knots for every stage of flap. Increase any of those by 10 gets you the icing speed. So I'll turn this into a PDF and try and attach it to the video description somehow. So we're all set to go here. It's a bit of a dark, gloomy day. We can see it's raining, overcast, 10 degrees on the ground here. So with icing conditions as well, so they're defined as plus 5 degrees Celsius or 41 Fahrenheit in visible moisture. Now we can see there's a lot of visible moisture up there, and we've only got 5 degrees to go to it, so typical lapse rate would be 2 degrees per 1,000 feet, so we should see icing around about 4,500 to 5,000 feet out of here. Outside of that, we're all set for a takeoff. We're going to do ECS off, so both low pressure and high pressure bleed valves are closed because we need all the power we can get. Auto caution's on, everything is all set. Alright, so the brakes are already off. We'll go into takeoff inhibit and we'll start the timer. There it goes. Alright. Now bringing up power levers through the 64 degree angle, we'll get auto caution arm light come out. Turn on the CTOTs, just using a key command for that. And we're all set. So maintaining directional control with the rudder as we come down the runway. If we need to, we're going to use ailerons to keep the wing level. So 123 is our V1 rotate V2. I'm going to use this vert sync button down here, which is mapped to my yoke. That'll sync it to the speed as we rotate. So down to 10 degrees nose up, using rudder to control the direction, keeping the wings level, confirming we have a positive rate of climb, select the gear up. Okay, now that pilot not flying would set the CTOT to max rated power, which is 108% and 930 degrees ITT. I'm not going to look down because I'm trying to fly the plane, so instead I'm just going to use the power lever to override the CTOT system, which is what they'd have to do anyway if the CTOT doesn't take it up. There it goes, too fast. Very twitchy in the simulator here. We'll leave it there. I'm going to bring up both flight directors, and the pilot flying is going to keep it on the live side of the heading bug here, so the right engine's still working, so I want to keep it on the right side of the heading bug. But we do also need to make a turn, so I'm going to set it to 353. Now, I'm also going to confirm that the prop has gone into a coursing mode, so you can see the prop gearbox oil pressure is out of the green arc, so that's what we want. Now I've got the skid ball roughly centered there, so I'm going to bring the yaw damper on. In a real aircraft this would start trimming the rudder for us. We still need to keep the pressure on the rudders while it does this. It's a bit trickier in flight sim because there's no force feedback. So it feels like it's about there. Oh, a bit too high with that nose attitude apparently. Alright, now I'm going to add in about 1 unit of aileron trim towards the live engine. Now this would be getting a little bit too close there again. So about there, so now I should be able to, once it's trimmed, I should be able to just let go of the yoke and it should stay relatively straight. That's pretty close, might have got a little bit too much aileron trim in there, looked like it wanted to roll. We'll turn the autopilot on. We've got heading and indicator, we're climbing at the V2 to V2 plus 10 range. Now on this SID we need to maintain this till 3,400 feet. Now the autopilot's got command, so it's going to want to come back to the centre of the bug, so I'm just going to knock it 2 degrees towards the operating engine, which is the right in this case. So it was 353, we got about 55, there we go. So it's 3,400, so I'm going to come right track direct Icaro. I'm going to do this very delicately because I still can't go beyond the 15 degree bank because that would be manoeuvring and we're not going fast enough to manoeuvre. So I'm just nudging the heading bug across. So still climbing, the MSA was 4,600, so we don't really need to rush anything at this point. There was an ATR a couple of years ago in Type A, I think, that accidentally got the wrong engine at this point and shut it down, so we just want to sit on our hands and do nothing. You can see we're at 6 degrees now, so we're about to enter icing conditions, so I'm going to turn the engine anti-ice on and boots to continuous. To set max continuous power as well, so we're at 4 minutes 40. So what we're going to do is bring the CTOT controller back to about 98%. So the power levers have overridden it at this point, so I'm just going to slowly bring the power levers back now. Alright, there we are. So now I can just bump them back up to around about 100. Which is going to be too much. 917 is the ITT limit, so we'll set it about there. Bring the CTOT off, so we got our max continuous power set, and that's why we were timing. Now we're just about to come up to the MSA. So once we get to the MSA, we want to accelerate. So we're in icing conditions now, we have engine anti-ice on. We need to accelerate to V-clean plus 15, which is 146 knots. And obviously when we're below the MSA, the terrain's going to kill us first, so we want to get above that, which is why we're still at best angle. Alright, so that's the MSA, so I'm going to engage out, lower the nose, start accelerating. I'm going to use vert sync again as the speed comes up through. We need to get to 146, going to go about 143. I'm going to go back into indicated, the speed will then come through and I can then use vert sync to correct it. Probably about there. So the speed's still increasing, and I can just hit vert sync, and it's going to resync to it. Looks like we've captured 145. That'll be 1 knot's not going to be disastrous to us, so we'll leave it there. Okay, so we don't want to go to 9,000 anymore. That's probably a bit excessive. We're above the MSA to the north. From here, there is a northeastern arc onto the ILS. So we might track by that. So, where are we? Tablet. At 6,000 feet, so you can see we're within this sector here, 4,600. We want to intercept this 1.3 DME arc, so the minimum on that 6,000, so I'm going to set 6,000, we'll capture that instead. So just going to come due east now, because we're going to track out to this, well, we're already at 12.3 DME here, so start with 130 and see how that looks. So we want to intercept this 13 DME arc. We've got plus or minus 2 DMEs, and we've got too much bank here as well because we're only at 15, not 25. So again, half bank would be on. We should have been a little bit slower with the heading bug movement there to make it do what we wanted. And we're just going to monitor it. So if it's still increasing, I'm going to go 15 degrees to the right. If it's decreasing, then we're going to hold it here and see how we go. We've got plus or minus 2 DME, and we'll just monitor that as it comes through. Now we better do some abnormal checklists now, so before we get too excited, we're going to double check that we do have what we think we have. So we've got the left torque read 0, the left temperature is 20 degrees, and the left fuel flow is 0. So it appears that the left engine has failed. We're going to do our memory items, so that would be to move the power lever to what would correspond to 20 to 30% torque, and this is just confirming that we do have the correct thing. So we're going to stand the power lever basically straight up, that'd be 20 to 30% torque. That'd still give us a slight forward thrust vector if it was the wrong engine. If we go all the way back to flight idle, it'll give it the air loading on the prop will kind of act a little bit like an air brake, and we definitely don't want to do that when we're already in quite a compromised state. So we've confirmed that now. You can bring the left condition lever to fuel off. And again, we just want to double check that it's definitely feathered, so there's no prop gearbox pressure. And we'd have a bit of a squiz out the window here if we can see it. So we would be looking to see if it's slowly rotating and try and see if we can see the blade front onto the airflow. Alright, so we'll just let it capture here. Yeah, how are we tracking? 12.6 still, so it looks like we're doing pretty well on the 13 DME arc, so we'll just keep nudging it around every so often. So we've gone into outs mode, we're capturing now. Now now that we've done our memory items, we'll just consider what's going on. So we're at max continuous, we've got 909. We're going to open the right high pressure bleed valve for the boots now, just to make sure they do have enough pressure to keep the ice off our wings. We're at 2 degrees, we are in icing conditions, we've got the engine anti-ice on, we don't need prop ice at this temperature, that's -5 or lower. And we're maintaining, I've got about 90% set there, so that's a reasonable number. It isn't going to be flogging this one engine that's still surviving. We don't need 100% at 917 anymore. Max continuous is probably a bit excessive because we're happily maintaining. And in fact, we're coming up through the minimum speed for half bank off in icing conditions as well. So we're going to just rebug 160 knots now. Alright, we're at 13.4, so I'm just going to knock us right 15 degrees. Okay, so now that we're happy with the aircraft stable, we're going to look at, we're going to actually pick up the checklist now. So the engine failure shutdown checklist. It's just going to confirm what we've already done. So the power lever to 20-30%, which we've done. The condition lever is fuel off. So I'm going to give us a caution about the prop not feathering, which is irrelevant because it did feather, in which case we need to activate these manual feather pumps up here. And it's also going to give us a note that following an engine failure it is a requirement to disconnect the autopilot and retrim the aircraft before re-engaging the autopilot. And that's just purely because if for some reason the autopilot trips out, we don't want it to just savagely drop a wing on us. So we just want to make sure that the aircraft is roughly in trim. So now that that's done, we can bring the power lever back up to match the other one. We always want to try to use the power levers as two. We don't want to end up in a scenario where we have to go around for some reason on one engine and accidentally push this one up when this is the one controlling the live engine. So we always want to keep it as standard as possible. Alright, so from here the next thing we want to do is secure the engine. So that's going to tell us to turn everything off that's on the broken side. So we're going to confirm the prop sync is never turned on, so that's already off. The generator switch for the failed side, which is the left, we're going to turn that off now. We do have the bus tie light, so we've got the energy from the right generator coming through the bus tie onto the left buses. Prop de-ice is turned off, the engine anti-ice on the left side is turned off, the air conditioning cross valve we do have closed, and the bleed and HP valve switches, well we've just opened one of the HPs, but they would be closed, and we'll set the transponder to TA only, because we don't want to get a climb command out of the TCAS when we're not really going to be capable of doing that. Slightly less abruptly here. Okay, so from there we can move on to a after takeoff checklist. Again, it's out of the abnormal section because we've got one engine shut down. So the gear is up, flap is at 0, the takeoff inhibit light is out, the CTOT is off. Max continuous power we already have set, because we only had 5 minutes, we're up to 13 already. Auto Corson switch can now come off. Now, the reason that we've left that so long is that if we had have turned that off, and the Auto Corson was the logic that feathered this propeller, well, it didn't feather it, it coursoned it for us initially, so it set it to a minimum drag position. If we turn that off, the Auto Corson system is going to turn off, at which point the condition lever comes back to the primary controller, goes, oh, we want max RPM. All of a sudden you'd have a massive amount of drag. So you've got to be sure that it's turned off before you, the memory items are completed before that gets turned off. Crossfeed consider, so yeah, we probably do want to consider that at the end of this. Air traffic services, we'll assume we've made some kind of mayday or pan call as appropriate. Engine restart, yes, no. Now, that depends on why this engine failed. Obviously we don't want to try to start an engine that caught on fire or anything like that. That's probably got some severe internal damage. We're going to assume that we heard a really large bang before it went. There could be blades and all sorts of fun stuff shot out the back of it, so we'll leave it shut down. So we'll just balance this fuel. Now the aircraft, it's only a cross feed system, it should be just feeding off the opposite tank. In this sim it wants to cross pump it for some reason, but that's alright. So we're going to turn the failed side pump to override. That's going to pressure through the cross feed line. We're going to turn the cross feed switch on. Second standby pump light will come on because we've suddenly lost pressure on this side, so now the fuel's flowing through here up into the right engine. In this, however, it's going to go backwards through a check valve, which should prevent this, and crossfeed into the other engine. So I'm just going to set it around about 50 kilos higher on the operating side. It's about there. Turn the crossfeed off, and we'll set it back to auto. Alright, so how are we tracking? 13.7. Probably want to come out of CDI now. We're going to need this, say, 143 is the first. There we go, so 143 radial set there. So once we cross that, we can descend to 5,100. So we'll go into a approach checklist, and again abnormals because an engine's shut down. So the seatbelt signs already on, the external lights we have set. The flight attendant will assume they've notified and secured the cabin for us. Altimeters we have set, cabin pressurization, actually I never set in the first place. It's about 1800 feet here. The approach brief will assume we've completed in the CTOT. We're still going to set this just in case we do need to go around. It's far easier to flick the switches than to find 108% without over-temping ourselves. Ice speed we would have on because we're at 2 degrees at the moment. So the VREF max weight was 117. We're going to increase that by 10 knots for ice speed. We also have 10 knot increase because there's one engine inoperative. Now they're not cumulative, so all we need to worry about is 127. So I'm going to set the bug to 127. The low pressure bleed valve, we never opened it in the first place. We probably could have, as we weren't using all the power out of this engine, so we could have left that open if we wanted to. Or we could have opened it, I should say, once we were maintaining 6,000. We need to start a descent here as well. Again, I'm just using commands off the joystick that I've got mapped, so I'm going to set around about 40% torque. Actually, we might need less than that because we're going to need to keep the speed back shortly. Where are we at? 14, so I need to come in a bit more. So the cabin is secure and the crossfeed is closed. So we're all set to go into the approach. Now I'm going to set 348 as the inbound track. The lead radial, I'm probably already through it, so it's still going on that other stuff there. Alright, yep. So we need to turn in. So I'm going to turn onto a 30-degree intercept. We've got out, so we're just capturing 5,100. Course bar is active though, so oops, go back to heading, bring up the localizer, that would help. Alright, so we'll go back to heading. So we're on 30 degree now, the course bar is active, approach mode. So we got localizer 1 is now active, glide slopes armed. There we go, so it's capturing the localizer, bring the heading bug around with it. Don't know why that's going off, we're at the published altitude here. Now we're going to need about 80% level, so we got about that there. We have what we need. So about to intercept the glide slope. We don't want to go too early because obviously there's only one engine. We don't have a massive amount of power. So out here, gear down. Condition lever is already max. And I'm only going to set flap 7 because we're at a degraded climb capability. That configuration, we should be around about 65 to 70% torque. Now I'm just going to add a little bit more rudder trim off to the left there. Again, the yaw damper should be doing that for us. Okay, in the missed approach, it's track 348, climb to 5,100, so we'll leave 5-1 set. Final approach point on this is at 4 DME on India Charlie Bravo, which is the localizer, so I'll knock that forward so we've got lock 2 distance. At 4 mile, that should be 3140, so that's what we want to check. So we're at 5 degrees now as well, so we're just about to exit icing conditions. We go 6 degrees, so we're out of icing now, so the engine anti-ice has to stay on for 5 minutes, but we can bring the boots back to off. I'm going to close the high pressure bleed valve as well. So that'll be at 2.5, we'll probably be on the runway by that point. There we are, we're visual. I'm just going to bring the power back just a shade under 60% now, just let the speed come back to about 160. 4 miles was the Maltese Cross, the final approach point. We're not far off that now, we're good for flap 20, so we're going to take that. Okay, so flaps 20 is selected. Just going to bump the power back towards 65%. So we want to try and hold 160 knots. Now we don't want to do flap 35 because we've only got one engine available. Flap 35 is too much for this condition. And we'll look at the final checklist now, again out of the abnormal section. So it starts with a caution. Both low pressure and high pressure bleed valves must be closed for an OEI go around, which they are, because we wouldn't have sufficient power to go around with those open. We'd just overtemp the engine. Flight deck door is closed, gear down 3 green. Condition lever is in max. Hydraulic pressure and quantity, so we're looking up the top here. We can see we have sufficient quantity, and we want to try and look at the brake accumulators. So we've got nearly 3,000 in the left and about the same in the right, so we have brakes available. Flaps 20 set, landing clearance received, and the yaw damper will come off with the autopilot. Final checklist is complete. Alright, so we're just going to let the autopilot do its thing here. We don't really want to get below VREF plus 10, so we're coming back towards 140, which is fine. Just going to add a bit more rudder trim in again. There we go. Alright, so we might disconnect the autopilot now. Ready for any transient forces because it's not quite kept trim right for us. I just want to gently bring it across, very, very smooth with our power lever controls. As the power changes, the loading on the aircraft will change. We'll get the wanting to swing around on us. Alright, so we're down again, very slowly over ground idle. Might even take a little bit of reverse and just let the aircraft roll out. We've got a heap of runway here. Now if we're too quick as we do that, it's going to cause quite a severe swing, and we'll find the nose shooting off all over the joint. So we'll bring it to a stop. Now I never got on the steering tiller, which is why I lost rudder effectiveness at the end there. There we go. So I'll bring it to a stop, set the park brake. We're now going to assess the condition of the aircraft. Are we on fire? Is there any reason for us to run from this thing as quick as we can? In this case, no, we're not. It was just an engine failure. We're perfectly safe at the moment. So from this point, we do our after landing flow and then consider vacating the runway. In this case, I'm not going to be able to because max power on one engine in X-plane, the ground friction's just too much and she won't go anywhere with reasonable control. So that was the basics anyway of an engine failure, then joined a DME arc and then came back via the ILS. Hope you've enjoyed this video. If you've liked it, give us a like. Any comments, drop a comment for us, and we'll see you in the next video.